Suppose that the function h is defined for all real numbers as follows. So we have the function h of x is a piecewise function. So h of x is equal to negative 1/3 x squared plus 5 if x does not equal negative 2. And we also have that h of x is equal to negative 4 if x is equal to negative 2. So we have two different equations on different parts of our domain. Now this question is asking us to find h of negative 5, h of 2, and h of negative 2. So to begin here, let's simply think about these two equations. We have equation 1 and equation 2. So thinking about equation number 1, we have that h of x is equal to negative 1/3 x squared plus 5. Now this is if x does not equal negative 2. So let's think about this domain. So if we really quickly think about a x number line, and we'll say right about there is negative 2. And we know if we move to the right-hand side of negative 2, we are approaching infinitely positive numbers. If we move to the left-hand side of negative 2, we are moving towards an infinite number of negative numbers. Now, this equation exists for everything except negative 2. So we want to put a hole there at negative 2 because x cannot be equal to this value. X could be anything else, though. It could be anything greater than negative 2. It could be anything less than negative 2. So from this number line, we can see that this interval of x values, this is where x is an element of the interval from negative infinity to negative 2. And we use a round parentheses there to exclude negative 2. And we are uniting this with the interval from negative 2 to positive infinity. So any other number except negative 2 will work in equation 1. And now, with equation 2, we have that our function h of x is equal to negative 4, and this is if x is equal to negative 2. So equation 2 is only going to work for one x value. It's only working when x is negative 2. So with these domain restrictions in mind, let's go ahead now and evaluate at the specified x values. So we'll say part A. We want to find h of negative 5. So here we have that x is equal to negative 5. So we can certainly tell by looking at this that negative 5 does not equal negative 2. So this means we've got to use equation 1. And we can confirm this by plotting negative 5 on our number line. So we say negative 5 lives somewhere over here. So to evaluate the function at x equals negative 5, we are using equation 1. So that is negative 1/3 multiplied by a negative 5 squared plus 5. So this is minus 1/3. Negative 5 squared becomes 25 plus 5. So let's rewrite this so we can easily find that common denominator. We have minus 25 over 3 plus 5. And so to get that common denominator, I'm going to think about 5 as being 5 over 1, and then we'll multiply the numerator and denominator by 3. So this leaves us with negative 25 plus 15, all divided by 3, which simplifies to a beautiful final answer of negative 10/3. So there we have it. The answer to part A is negative 10/3. Now for part B, here we're asked to find the function h's evaluation at 2. So we can see here that x is equal to positive 2. And again, we can certainly see very quickly that 2 does not equal negative 2, meaning that we are going to need to use equation 1. And again, we can confirm this by plotting x equals 2 on the number line. So So we'll say x equals 2 is right about there. So here we go. We are going to evaluate using equation 1. So we have h of 2 is equal to negative 1/3 multiplied by 2 squared plus 5. So we have minus 1/3. 2 squared leaves us with 4 plus 5. And again, let's rewrite this. So we have negative 4/3 plus 5. And in order to combine these two numbers together, we need a common denominator. So if we rewrite 5 as 5 by 1, and then multiply the top and bottom by 3, we attain that common denominator. So this is leaving us with negative 4 plus 15, all divided by 3, which leaves us with a beautiful final answer of 11/3. Beautiful! Now, last but not least, part C is asking us to find the function h's evaluation at negative 2. So we can see here that x is equal to negative 2, which means that we are going to need to use equation 2. Woohoo! So this one's a nice and quick one. We can see by definition of this function that h of negative 2 is equal to minus 4. And this completes our example and is our beautiful final answer.